Hi, Math 1. Let's take a look at the task 3.7, which is identifying function values and interpreting them. So take a look at this graph here, okay? We're going to see if we can identify inputs and outputs. This graph shows time in minutes, and there's number of people in line. All right, so I noticed that there's 3 people in line, and then there's 6 people in line, okay? And they're calling this graph, this function a of x. When it says determine the value of a of 2, we're going to go to 2 as the input, okay? So that is the input value, or the x value, and 2 takes us right here, okay? And the answer is 6. Now when it says explain the meaning, I have to make sure I state these 2 numbers and the 2 words for the story. So this story is talking about minutes, and it's talking about number of people in line, okay? So at 2 minutes, okay, there are how many people in line? The answer is 6. There are 6 people in line. So the important thing is you state 2 numbers and you state 2 words, input and output. Okay, determine the value for a of 6. So let's go to 6. Okay, let's go to 6. This is the x, that's the input. Here's 6, and 6 takes us all the way up here to this point, okay? And that has a y value of 12. So when 6 goes in, 12 comes out. Explain the meaning. Okay? And 6 goes with minutes. So at 6 minutes, there are 12 people in line. There are 12 people in line. It looks like the people in line just keep getting greater and greater. All right, number 3 is a little different. A of x equals 9, okay? This is not the input, okay? X is the input, and 9 is the output. The output, or the y value. So now I'm going to go look on the y-axis, okay? And when is there 9 people? Okay, when does that happen? That happens all the way down here when x equals 4. This is the x-axis when x equals 4. And let's interpret that using a sentence, okay? At 4 minutes, there are 9 people in line. Okay. All right, write an equation for a of x. You can do it from a graph, or you can go ahead and do it from a table. So if I take a look at x and a of x, okay, the starting point right here is 0, 3. We have 2, 6. We have 4, 9. So what's happening to the y values? They're being added by 3. The x values are getting added by 2. So delta y over delta x is 3 halves. You also could have gotten that from the graph, rise up 3, and then over 2, the slope of that line. Okay, so this is a straight line, and here comes the equation. The starting output is 3. That is the y-intercept. And then the slope is plus 3 halves, and it's just going to be x since our starting input is 0. So that is an equation for a of x. All right, let's keep going. Inputs and outputs. Take a look at these 2 stores. So here's a of x. So store a of x has that same graph we just examined. Okay. Time is in minutes. And the number of people in line. Okay. Now store b of x, their information is in this chart here, in this table. Okay. It also has time in minutes, and then there's people in line. Now there is some differences here. There is some differences because here we started with 0 and we had 3 people in line in the beginning. And here we only had 1 person in line. Okay? And then what's happening here? Every minute it's going up by 2. It's going up by 2. So this is a little different of a pattern. Over 1. This is 2 over 1. Okay. Remember the slope here was up 3 over 2. Up 3 over 2. All right, let's answer some questions. Gustavo observed that A of 6 is 12. Is that true? Let's go look at store A. A of 6. Okay. Does that indeed take us to 12? Yep, it sure does. That is true. What does that mean in the context of the problem? Well, it means, okay, at 6 minutes, okay, there are 12 people in line. 12 people in line. Determine the value for B of 6. Okay, let's make sure we go look at the B table. Look over here, B of 6. So when 6 goes in, okay, that's the input. When 6 goes in, right here, 13 comes out. 13 comes out, okay? Interpret the meaning of the input and the output. Okay, so when 6 goes in, that was 6 minutes. So let's say at 6 minutes, there are 13 people in line. You just have to make sure when you say your sentences that you say 2 words, okay? The minutes and the people. So the titles of these 2 columns here in your chart, or the 2 titles on your graph. You have to say both of those. How many people started in line at store A? Let's go at store A, okay? When it says start, that means in the beginning, okay? And it looks like at time 0, there was 3 people in line when this started, okay? There were 3 people. Oh, let's say when 0 goes in, 3 comes out. Okay, remember when it says started and you're looking at a table, you're going to have a 0 for X and 3 for the Y. X is the input and A of X is the output. How many people started in line at store B? Well, let's go see. At store B, the number of people in the beginning was just 1. It was just 1. Okay, so let's put right here, 0 is the beginning and 1 is the output. If you had to look at a chart, 0 and then B of X, the input is 0 and the starting output was a 1. Find the time when A of X equals B of X. Okay, so we got to find a time when they're equal. So let's go see. 0 did not match. No 1. Does 2 match? 2 takes us to 6, but here 2 takes us to 5. Let's see. Does 4 match? 4 for store A gives us 9, and 4 gives us 9 for store B. So we found the matching point. 4 and 9. 4 and 9, okay? But what did they want us to say? The X value. The X value was 4. Okay, so what does that mean? At 4 minutes, okay, they had the same. So I'm going to say both stores have 9 people in line. Write an equation to model the number of people at store B. Okay, store B, B of X equals B of X. What is the starting output? Let's go see. Starting output was 1, and then the pattern is +2. Okay, and then we have just an x since the table started at 0. All right, let's go take a look at a couple more graphs. Okay, sometimes you could be given a graph and a table at the same time. Okay, whenever you're explaining the meaning of a value, you should make sure you have 2 pieces of information. Okay, make sure you state the x value, that's a number, okay, and the meaning. Okay, that's the units. And then same thing for y. Make sure that you say the y number, okay, and the meaning of the value, which is the units. Okay, so a number and a word, a number and a word. Okay, here's Gustavo's pool. It looks like gallons of water. He started with 24,000 gallons of water, and it looks like he's losing water. Okay, this is minutes. Time is passing, and he's losing all of his water, and then he has no water. Okay, Christine's pool, okay, she has 27,000 gallons of water, so she has more. She's also losing some water. Okay, find g of 4. We have to be super careful that we use the right function. The g of x is the graph, and the k of x is this table. So for g of 4, let's go look at g. When 4 goes in, okay, what's this value? 20,000. 20,000. And let's explain our answer. We have to use 2 numbers, 2 words. So the words are going to be minutes, okay, and gallons. Minutes and gallons. So at 4 minutes, I think I'm going to be fancy and even say that this is Gustavo. Gustavo has 20,000 gallons of water in his pool. Find k of 4. All right, let's go look at the k. Let's go look at Christine's table. K of 4 takes us to 21,600. So 4 goes in, 21,600 comes out. Let's explain the answer. Okay, so at 4 minutes, so the words for a table are up here at the top. Okay, 4 minutes. How many gallons of water? Christine has 21,600 gallons of water. Oh, and here's that fun one where we have to find where they're equal. Where does the g of x equal the k of x? All right, let's see if we can find the matching point. 0 doesn't match. 1 doesn't match. 4 didn't match. Let's see. These aren't even nice points. Does this match? Let's see. Does 8 give us 16? Oh, it does. I found the matching point. 8 minutes. Christine has 16,000. And at 8 minutes, Gustavo also has 16,000. Okay, so what's the x number? The x number is 8. And let's explain the meaning. At 8 minutes, both of them have 16,000 gallons of water, okay, in their pools. Okay, so we found the matching point. All right, just to recap what we learned, okay? Function notation is the way of showing the relationship between the inputs and the outputs of a function. Okay, so when you're looking at this notation, the inputs, okay, go there inside the parentheses. Those are the inputs. Okay, and then the outputs are over here on the outside of the parentheses. Those are the outputs. Okay? And there's 3 ways you can do this. Okay? If I give you a table, okay, here's the input. Inputs are x, and then the outputs are the y's, or the f of x's. So if I asked you to do f of 3, you would go to the table, and when 3 goes in, 2 comes out. I could also ask you to go backwards. Okay, so this is the input. Your job is to find the input if 20 is the output. Okay, so right here, 20 is the output, and what's the input? What's the x? 6. Okay, you can also be asked to look at a graph and determine input outputs. Okay, so when it says g of 3, that's the x value. So we go to 3, okay, and we try to find the point, and the output value is 1. I can also ask you to go backwards, okay? So x is the input, that's the x value, and this is the output value. So we're trying to find -3 for the output, that's the y value, and that's right here, okay? And the x value for that, the x value is 5. When 5 goes in, -3 comes out, so the input must be 5. We can also ask you to evaluate by looking at an equation. Okay? And what that looks like, okay, here's an equation. They would tell you what input to put in. So you're going to make, here's the input, x is the input, and that's where you put the value. So if I needed to calculate h of 1/2, I would have to put 1/2 into the x place and then calculate this answer. So what does h of 1/2 equal? -4 times 1/2 is -2 plus 1. So h of 1/2 is -1. You could be asked to calculate by inputting values into an equation. Thanks, Math 1.